In this video, I'll show you how to integrate using inverse trigonometric substitution. This is question 6 in the series. The function that we'll be integrating in this video looks like this, where we have to integrate x to the power of 3 over the square root of 16 minus x squared dx between 0 and 2 times the square root of 3. To integrate this function, you'll need to know how to use inverse substitution. And when it comes to inverse substitution, you have to substitute part of your function with one of these expressions. Now, which of these three expressions matches ours? Take a look. We have minus x squared, and here we have minus x squared, and they have a to the power of 2. So what could a possibly be for 16? 4. 4 to the power of 2 is 16. So if your function matches one of these expressions, you have to set x equal to the following. And in our case, it will be x is equal to 4 sine theta. The next step is to take the derivative. If you take the derivative of this equation, you end up with dx is equal to 4 cosine theta d theta. Now, because we are switching our function from one that's in terms of x to one that's in terms of theta, because after replacing this x with 4 sine theta and this dx with this expression, you'll have a function in terms of theta. If you do that, your lower and upper limit will change. To find your new lower and upper limit, you have to solve for theta in this equation. So x over 4 is equal to sine theta. And now I'll take the inverse of the left side, where I have sine inverse x over 4 is equal to theta. What I have to do now is substitute this 0 into the x, find my new value, and then substitute 2 times the square root of 3 into my x and find my new value. And here's how. When x is equal to 0, you have sine inverse of 0 over 4. That's like saying, what is sine inverse of 0? Let's use our calculator. Sine inverse of 0 is 0. So this becomes 0. But when x is equal to 2 times the square root of 3, we get something different. So let's substitute this into there. We end up with sine inverse of 2 times the square root of 3 divided by 4, and we get pi over 3. So our new upper limit is pi over 3, and our lower limit stays at 0. So let's rewrite everything using theta. So we have the integral between 0 and pi over 3. Remember, we replaced x with 4 sine theta. So I'll write down 4 sine theta to the power of 3. And remember, our dx is now 4 cosine theta d theta. And over here we have 16 minus 4 sine theta to the power of 2. My next step is to simplify as much as I can. And one way I can do that is distribute this power of 3 to the two components here and factor out a 16 from these two terms. Because after you distribute this 2 to the 4 into the sign, 4 to the power of 2 is 16. Here's what I mean. And I'll show my work over here and then place my work in the next step. So I have the square root of 16 minus 16 sine squared theta. I will factor out a 16, where I end up with 16 bracket 1 minus sine squared theta. I can now distribute this radical to the two components here. Remember, this is a product of 16 times this. So if I distribute my radical to the 16, I end up with simply 4. And the rest stays the way it is. And I'll use the identity cos squared theta plus sine squared theta is equal to 1, where I can then replace this with simply cosine squared theta. The reason why cosine squared theta is more ideal than 1 minus sine squared theta is because you can now get rid of this squared because of the radical. So you end up with 4 cosine theta only. Remember, this square root will get rid of that squared value. I'll now replace 4 times cosine theta into here. But what's nice about this is that this 4 now will cancel out with that. This cosine will cancel out with that. And we're left with simply the integral between 0 and pi over 3. And this 64 can be dragged outside. Sine to the power of 3 theta d theta. Excellent. To integrate sine to the power of 3 theta d theta, we have to break down sine to the power of 3 into sine to the power of 2 and sine. And here's why. By doing that, you end up with this function. You have sine to the power of 2 theta and sine theta d theta. And once again, I can use the identity that I used up here, where I said cosine squared theta plus sine squared theta is equal to 1. Essentially, what I can do is take this cosine squared theta to the other side, where I have sine squared theta is equal to 1 minus cosine squared theta. And replacing this with 1 minus cosine squared theta is a lot better, because then you can use u-substitution, find the derivative, and then cancel out the sine. If we do that, we end up with, and now I'll do a u-substitution for simply cosine, where I have u is equal to cosine theta. I have to find the derivative of this now, where I have du is equal to negative sine d theta. I just did a u substitution, and just like before when I substituted part of the expression with x, I had to find new lower and upper limits. Once again, I have to find new lower and upper limits because of this switch. So what I have to do is replace this 0 into here, find a new lower limit, place this into there, find a new upper limit. So here's how to do that. U is equal to cosine at 0. We know cosine at 0 is always 1. So that is our brand new lower limit. And I have to replace this into here as well. So I have u is equal to cosine pi over 3. Using our calculator, cosine pi over 3 gives us half. This right here is our lower limit, and this right here is our upper limit. So let's rewrite the function in terms of everything we know. So we have 64, that part didn't change. Our lower limit is 1, our upper limit is half. We have 1 minus u to the power of 2. Sine theta doesn't change. D theta is equal to du over negative sine theta. All I did was isolate for d theta here by dividing both sides by negative sine theta, and that's what I get. This part cancels out with sine. This negative can be brought outside of the integral, where we have negative 64 half 1 minus u to the power of 2 du. This part is relatively easy to integrate. 1 minus u to the power of 2, that becomes u minus u to the power of 3 over 3. And now we have to find what this is equal to between 1 and half. So we have negative 64. We're going to evaluate this at our upper limit, where we have half minus 0.5. I'm not going to write down half for this, to the power of 3 over 3 minus our lower limit of 1 minus 1 to the power of 3 over 3. Close the square bracket. Now it's a simple matter of putting this in our calculator, where we have negative 64 bracket 0.5 minus 0.5 to the power of 3. I want to put this in brackets as well. Minus, so we're here now, bracket 1 minus 1 to the power of 3 is 1 over 3. Close the bracket, close the last square bracket, and we're left with 40 over 3. 40 over 3, this number, represents the area of this function between 0 and 2 times the square root of 3. And so there you have it. That is how to integrate using inverse trigonometric substitution. that concludes the series.